Hello students, today we will start with a microscopic phenomena, diffraction phenomena called RHEED. The full form of RHEED is reflection, high energy, electron diffraction. So this is the R, this is the RHE, this is the E, and this is the D. Now, if the electrons have been accelerated, for example, if the electrons are fast, and they have been accelerated with a voltage of 30 to 100 kilovolt, and they undergo diffraction. While they are undergoing reflection or transmission. So, in the case of transmission, we call it it's called TEM, and we get an SED pattern. While in case of reflection, we get a RHEED pattern. Now, if the incidence has been done at a grazing angle, means close to 1 degree, since the wavelength of electron is small at such high voltage, that is it's about 0.037 angstrom for 100 kilovolt acceleration. This is the wavelength. Then what happens? The crystal tend to have a particular zone axis. And they are oriented in a common direction called fiber axis. Fiber axis. And the orientation is then called fibrous. The diffraction pattern then consists of arc rings, arc ring of definite symmetry. and the extent of arc this will depend on the spread of the fibrous orientation, depend on spread of fiber orientation and the crystallite size. So these are the two things on which the extent of the arc will depend. Now, if again the surface is automatically smooth, surface is atomistically smooth, the reflection diffraction spots become streaked. The reflection diffraction spots they become streaked or elongated. Streaked or elongated at right angles to the shadow edge. At right angles to the shadow edge. So smoothness causes streaked and elongated patterns of the spots. And this shadow edge, it is an edge which occurs because of very limited penetration of the electron below the surface. Penetration of electron below the surface. Now, the elongation, so the elongation, mathematically we can say that elongation is approximately equal to inverse of penetration depth. The lower is the penetration depth, the longer will be the elongation. And now what have been observed is that thin crystals they have a reciprocal lattice, which consists of spikes perpendicular to the plane containing the thickness. Spikes perpendicular to the plane containing the thickness. Now, this is due to the fact that due to the very small value of the wavelength lambda, the electrons, the radius of the evolved sphere is quite large. Radius of evolved sphere is large. EWS stands for evolved sphere. This is quite large. So it intersects along sections of the spikes to elongated spots. So intersects with section of the spikes to get elongated spots. So by elongated spots, I mean like this. Usually spots are like this, but we are getting spots like this. So this is due to the fact that if there are this is the spike. So since it is long, it will interact, projecting say like this. So these interactions are elongated. That is why we are getting elongated spots. And if the film thickness is decreased, the film thickness is decreased, and the increase in smoothness the spikes then tend to form lines. So we can summarize that if the surface is smooth, and the electron beam is appreciably reflected. Number two is because of the inner potential, diffraction discrete amount in each spot. The diffraction is in discrete amount in each spot. And if there are, however, undulations on the surface, if this is the case, then the amount of refractive shift decreases. The refractive decreases, and distance between the refracted electron beam and shadow increases. Distance between diffracted E-beam and shadow edge, it increases. And so basically we are getting asymmetrical streaks as the semicircular arc of diffraction ring from very smooth polycrystalline surface becomes slightly U-shaped. From very smooth polycrystalline surface, it becomes slightly U-shaped. And when the electron beam penetrates, the surface, then the transmission diffraction patterns are observed. And with increasing roughness, as the average roughness increases, the streaks change to a mixture of streaks and spots. So initially it was only streaks for very smooth surface. Now, as the electron is penetrating the surface, so instead of only getting the electron diffraction, we are getting a mixture of reflection as well as transmission diffraction pattern. So from streaks it changes to a mixture of streaks and spots. The streaks are for the reflection electron diffraction pattern, the spots are for transmission electron diffraction pattern. So pictorially we can see that it is very smooth, right? So it is coming down and electron is coming up. Here we are getting smooth streaks like this, and a little bit if the roughness increases a little bit. So initially when we like this, little bit of roughness is there. So it will be initially a combination of streaks and spots. And if it is totally rough, then it will be only spots, like in TMSAD. Okay. So again, it will be spots for semi-crystal, for polycrystal. It will be again ring pattern, and for amorphous it will be hat pattern. So this is for polycrystal, and this black one initially was for single crystal.